Example 1 says, fill out the following tables knowing that the square root of 2 divided by 2 is approximately equal to 0.7, and try to sketch each graph by connecting the points. Can you predict the rest of each graph? So let's look at part A. We have some input values here, and we have our output values being sine of x. So sine of 0 is, if we think about the unit circle, 0 is right here, and we know that that point is 1, 0, and the y-coordinate there is 0. Pi over 4, the y value is the square root of 2 over 2. At pi over 2, that's at the highest point on the unit circle, and that's 0, 1, and we know that the y value there is 1. For 3 pi over 4, that's going to be square root of 2 over 2. At pi, that's going to be at the leftmost point on the unit circle, and that is negative 1, 0, so our output value would be 0. At 5 pi over 4, that is going to be the negative square root of 2 over 2. At 3 pi over 2, that's going to be the lowest point on our unit circle, which is 0, negative 1, and the y value there is negative 1. For 7 pi over 4, it's going to be negative square root of 2 over 2, and then 2 pi basically takes us back to where we started, and the y value there is 0. So here is our y-axis, here is our x-axis, and the highest value is going to be 1, and the lowest value is going to be negative 1. So we're going to be working, notice that all of our x values are positive, so I'm going to be working on the right-hand side of the y-axis, and I've marked 2 pi here, and I'm also going to mark pi by estimating halfway between 0 and 2 pi, and I'm going to try my best. It looks like it would be about right there, so I'm going to mark that off with pi, and then pi over 2 is going to be halfway between 0 and pi, and so that looks about halfway. So I'll put pi over 2 right here, and then pi over 4 is going to be halfway between 0 and pi over 2, so that's about right there. 3 pi over 4 would be right there. 3 pi over 2 is going to be halfway between pi and 2 pi, and then halfway between pi and 3 pi over 2, we have 5 pi over 4, and then here in our last location, we would have 7 pi over 4. And so now I'm going to plot the whole number values. So when I plug in 0, my output is 0. When I plug in pi over 2, my output is 1. When I plug in pi, my output is 0. When I plug in 3 pi over 2, my output is negative 1. And then when I plug in 2 pi, my output is 0. And I'm going to try to plot the other points as well. And remember, square root of 2 over 2 is approximately equal to 0.7. So I'm keeping that in mind as I am plotting these other points here. And this is a really rough sketch. So hopefully now with these dots, it's kind of like connect the dots as a kid, and now I can connect those to see what our graph is going to look like. And I'm going to try my best not to fudge this up. All right, that wasn't as bad as I thought it was going to turn out. I mean, it doesn't belong in a museum or anything, but I think that's as good as it's going to get for me. Okay, so now we have graphed one period of our sine function. And remember, because sine is a periodic function, and because the period is the smallest value where basically f of x plus p is equal to f of x, if we continue on the graph, it's basically going to take on the shape that we have here. And the way that I like to explain it is basically if I took this pink curve and I copied and pasted it, that is what the rest of the graph is going to look like. So basically, I'm just copying it and pasting it on both sides between 0 and 2 pi. So I could paste it on this side as well, but I'm going to run out of room on the right side. So it's just going to look something like that. And that's what the rest of the graph is going to look like. And I'm going to put little arrows here to indicate that it's going to go in both directions forever, because recall that for y equals sine of x, the domain is all real numbers. And so the graph is going to go on forever in both directions. And here, hopefully you can recall that the range is bracket -1, comma 1 bracket. And so that is how we graph the sine function. All right, part B wants us to graph y equals cosine of x. So let's go through a similar method. Let's draw our little unit circle for reference. And if we're starting off at 0, we know that the coordinates here are 1, 0, and the cosine value is going to be 1. At pi over 4, the cosine value would be square root of 2 divided by 2. Pi over 2, that's at the highest point on our unit circle, and the x-coordinate there is 0. At 3 pi over 4, that is like in quadrant 2, and it's going to be right here, and the coordinates of that are negative square root of 2 over 2, comma square root of 2 over 2, and so the x value there is going to be negative root 2 over 2. At pi, we have the coordinates negative 1, 0, so the cosine value there would be negative 1. For 5 pi over 4, it's going to be negative square root of 2 over 2. At 3 pi over 2, that's the lowest point on our unit circle, and the coordinates there are 0, negative 1, and so the x value is going to be 0. For 7 pi over 4, it's going to be square root of 2 over 2, and then for 2 pi, it's going to be 1. And I kind of went through this quickly, but just as a reminder, it's really important that you have a memorization of the unit circle. And I've done all the major angles like 0, pi over 2, pi, 3 pi over 2, and 2 pi, but you also want the like multiples of 30 degrees and 60 degrees. So you want to know, for example, the terminal point for 30 degrees, which is root 3 over 2, comma 1/2. And you want to make sure that you have all of those memorized. That's going to help you so much throughout the rest of the quarter, as well as when you reach calculus. So here is our y-axis, here is our x-axis, here's a y value of 1, here's a y value of -1, and I already showed you in the last example how I went about filling in my x-axis, so this time I'm just going to do that very quickly. Okay, so I've filled in my x-axis values, and now I'm going to go ahead and plot these points. And then now I'm going to go back and plot in all the square roots of 2's and the negative square roots of 2's, and these are all, I'm trying to approximate their location to the best of my ability. All right, so I have those filled in, and now this one is not nearly as good as my sine function, but hopefully you get the gist. And when asked what is the rest of the graph going to look like, this is again a periodic function. And so if I were to extend this, the graph would look something like that. It's supposed to be, you know, an exact copy. And so I'll put an arrow here, and I'll put an arrow on the right side as well to indicate that it's going to go on forever in both directions. And this concludes showing how to graph sine and cosine on the xy plane.